Mars is not a destination. It's a sentence. The first humans who land on Mars will not come back. Not because something will go wrong, because something will go exactly as planned. And we knew this before we started building the rockets. We knew it before the engineers drew the blueprints, before the astronauts were selected, before the press conferences and the countdown clocks and the flags planted in red soil for cameras that will broadcast to a planet 140 million miles away. We knew it, and we decided to do it anyway. That decision, that single, quiet, irreversible decision, is the most terrifying thing human beings have ever agreed to. So before you decide how you feel about it, you need to understand what it actually means to go. In 2022, Robert Zubrin, aerospace engineer, founder of the Mars Society, and the man NASA consults when it needs someone to tell the truth, said something that didn't make the front pages. He said that a one-way mission to Mars isn't a death sentence, it's a founding act. The first people who went to the Americas didn't have a return ticket, Zubrin told an audience at the International Astronautical Congress. They went to stay, and civilization followed. That reframe didn't comfort everyone, because here is the difference. The people on those ships could breathe the air when they arrived, they could drink the water, they could grow food in soil that had evolved alongside life for billions of years. Mars has none of that. Mars has a surface temperature that averages minus 80 degrees Fahrenheit, an atmosphere so thin it is 100 times less dense than Earth's, and made almost entirely of carbon dioxide, radiation levels that would deliver a lethal dose to an unprotected human in a matter of days, and dust storms that can swallow the entire planet for months at a time. Robert Zubrin is right that it's a founding act. What he doesn't say out loud is what gets founded first: a graveyard. We have been staring at Mars for a long time. 5,000 years ago, ancient Babylonian astronomers tracked its movement across the sky and named it after their god of plague and death. They watched it move in retrograde, that strange backward arc it traces every 26 months, and they didn't understand why. They thought it was the sky itself breaking. Every civilization that looked up at the red dot saw something wrong in it. In 1877, Italian astronomer Giovanni Schiaparelli peered through his telescope and saw what he believed were channels carved across the Martian surface. He called them canali. The word got mistranslated into English as canals. Canals, as in built by someone, as in there is someone up there. For 40 years, the civilized world believed Mars was inhabited. Then in 1965, 88 years after Schiaparelli's observation, NASA's Mariner 4 flew past Mars and sent back 21 photographs. The first close-up images of another planet in human history. No canals, no cities, no one. Just craters. Ancient, silent, frozen craters. The romantic Mars, the Mars we had spent millennia imagining, died in a single afternoon in July 1965. And yet, we kept going. Because by then, Mars had stopped being a fantasy and had become something more dangerous, a goal. In 1976, the Viking one-lander touched down on Mars. It was the first time humanity had successfully placed a functioning machine on the surface of another planet. Scientists around the world watched the data feed in real time. They had designed an experiment specifically to detect signs of microbial life in the Martian soil. A chemical test that, if positive, would be the single most important scientific discovery in the history of our species. The results came back ambiguous. Not negative, ambiguous. Some researchers argued the reaction detected was biological. Others said it was purely chemical. The debate has never been fully resolved. What Viking found in 1976, or didn't find, is still contested today, nearly 50 years later. That ambiguity is its own kind of horror. We went all the way to Mars and came back not knowing. Since that moment, we have sent 50 missions toward Mars. 26 of them failed. Engines cut out, signals went dark, spacecraft disappeared. Mars destroyed or ignored every one of them. We don't talk about this enough. The planet has a failure rate, and we're still planning to send people. There are names attached to this story. Real ones. Reed Wiseman, commander, former Navy test pilot. The kind of man who has already looked at the math and decided the math is acceptable. Christina Koch, the first woman selected to travel farther from Earth than any human being in history. She spent 328 days aboard the International Space Station in a single stretch, the longest spaceflight by a woman ever. She did it, in part, to understand what long-duration spaceflight does to a female body. She already knows some of what she found. She agreed to go anyway. Victor Glover, pilot, the first black astronaut assigned to a deep space mission. He has spoken about what it means to carry history on a rocket, about the weight of being the person who goes when others were not allowed to. Jeremy Hansen, Canadian Space Agency, the only non-American on the crew. He will look out a window at the moon from a distance no human has reached since December 1972. 52 years of silence before a human being gets that close again. These 4 people are not going to Mars. Not yet. They are going to orbit the moon on Artemis 2, a practice run, a dress rehearsal for the actual mission. But the people who will go to Mars, they exist right now. They are alive. They are training somewhere. Some of them are already selected and haven't been told yet. And at least some of them will not come home. Not because the mission fails, because the mission succeeds, and there is nowhere to come home to afterward. Let's talk about what the journey actually involves, because most people have no idea. The distance from Earth to Mars varies. At its closest, which happens roughly every 26 months during what astronomers call opposition, Mars is about 33.9 million miles away. At its farthest, it's 250 million miles. The average for a practical launch window is somewhere around 140 million miles. The fastest spacecraft we have ever launched, the New Horizons probe, travels at roughly 36,000 miles per hour. At that speed, it would still take 162 days to reach Mars during a good launch window. 6 months in a metal can. But here's what that means physiologically. In 6 months of microgravity, the human body loses up to 20% of its bone density. Muscle mass atrophies at a rate that makes it impossible to walk unaided when you arrive. Vision degrades, a condition called spaceflight-associated neuroocular syndrome, because the cerebrospinal fluid shifts toward the skull when there's no gravity pulling it down. Astronauts who spend 6 months on the International Space Station return to Earth unable to stand without help. They need weeks of rehabilitation just to walk across a room. When you land on Mars, there is no rehabilitation team waiting. There is no room. You step out of the spacecraft and begin working immediately, because every hour of every day on Mars is a resource calculation. The surface pressure on Mars is less than 1% of Earth's. The atmosphere, that thin, cold, unbreathable mixture of 96% carbon dioxide, will kill you in minutes without a suit. The suits themselves are a prison. Every time an astronaut goes outside, they are betting their life on seals and valves and a layer of material between their skin and a vacuum that would cause their blood to boil. But the suits are not the thing that will kill the first Mars colonists. Radiation will. Mars has no global magnetic field. Earth's magnetic field, the invisible force generated by our planet's liquid iron core, deflects the constant stream of high-energy particles the Sun fires into the solar system. We don't notice this because it works perfectly, silently, every second of our lives. Mars lost its magnetic field approximately 4 billion years ago. Its core cooled and solidified, and the protection went with it. Without that shield, the surface of Mars receives radiation levels that are, on average, 700 times higher than what we experience on Earth. A mission to Mars and back, including the time on the surface, would expose an astronaut to radiation doses that NASA estimates at roughly 1.01 sieverts. That's the equivalent of receiving a full-body CT scan every 5 days for 3 years straight. The lifetime cancer risk from a single Mars mission approaches 5% above baseline. That sounds manageable. Until you remember that baseline on Earth already includes every environmental exposure from birth. You're adding 5% on top of a number that is already not zero. And that's before a solar particle event, a solar flare, which can dump that same annual radiation dose in a matter of hours. The astronauts know this. They still sign the papers. Now add the dust. Martian dust is not like Earth dust. It is pervasive, electrostatically charged, and composed of particles so fine they penetrate every crack, coat every surface, and degrade solar panels at a rate that threatens the entire mission's power supply. The dust storms on Mars can grow to cover the entire planet, an area of 55 million square miles, in a matter of weeks. During the 2018 global dust storm, NASA's Opportunity rover, a machine that had been operating for 15 years, went permanently silent because the storm blocked all sunlight from its solar panels for months. Opportunity never recovered. A Mars base running on solar power faces that same darkness every time a global storm hits. Except the base has people inside it who need oxygen, heat, and food. Every single day on Mars is a negotiation between survival and entropy has never lost. But the body isn't the only thing that breaks. In 2010, the European Space Agency and Russia ran an experiment called Mars 500. 6 volunteers were sealed inside a mock spacecraft in Moscow for 520 days, the approximate duration of a round-trip Mars mission, without ever leaving. No windows, no sunlight, no contact with the outside world beyond a simulated communication delay. What they found was this. Within the first few months, most of the crew began sleeping more, moving less, and withdrawing from group activities. One participant spent 93% of the mission in bed outside of required duties. Reaction times slowed, cognitive performance declined. The experiment wasn't physically dangerous. Nobody was irradiated or starving. They were just locked in a room, and it nearly broke them anyway. Now imagine that same psychological erosion operating on a crew that cannot be resupplied, cannot be replaced, cannot quit. Where the simulation is real and the walls of the habitat are the only thing between human beings and a planet trying to kill them every minute of every day, the Mars 500 crew went home. They walked out a door in Moscow and drove to their apartments and slept in their own beds. The people who actually go to Mars will not have a door to walk out of. Here is what most people assume. We are going to Mars to come back. That we are sending explorers who will spend 18 months on the surface, the minimum stay required by the math of orbital mechanics, because you cannot leave until Earth and Mars are aligned again, and then return home as heroes. That's the story. The rockets, the flags, the landing, the celebration, and then the return. But that is not the story that the engineers at SpaceX, at NASA, at the European Space Agency are actually planning for. The real plan, the one written in the technical documents, not the press releases, is permanence. Elon Musk has said it plainly and repeatedly. The goal of SpaceX's Starship program is not to visit Mars, it is to create a self-sustaining city. A city of 1 million people within the next century. A city that, by design, does not need Earth to survive. And a city that does not need Earth to survive is a city whose citizens cannot simply fly home. What changed our understanding isn't the destination, it's the return cost. A round trip to Mars is not twice as hard as a one-way trip. It is approximately 10 times as hard. Because bringing enough fuel to leave Mars requires either sending that fuel ahead of time, a mission unto itself, or manufacturing it on the surface using resources that don't yet exist there. The Sabatier reaction can theoretically convert Martian CO2 and water ice into methane and oxygen for rocket fuel. Theoretically. No one has done this at scale, on another planet, under the conditions that Mars actually presents. What NASA found when it ran the mission architecture math was this. The first wave of humans on Mars will arrive at a base that is not yet built, in a body that is not yet recovered from the journey, with supplies that are not yet sufficient for departure, and they will need to spend the next 500 days building the infrastructure that makes leaving possible before the window even opens. 500 days. In 500 Martian days of construction, exposure, dust, radiation, and psychological isolation, the probability of at least one mission-ending failure approaches statistical certainty. Not because we're careless, because the margin for error on another planet is zero, and humans are not zero-error systems. The first humans to land on Mars are not explorers in the way Neil Armstrong was an explorer. They are settlers, and settlers, throughout all of human history, have always paid a price that the people who sent them never did. We have been here before, not on Mars, but in this moment, the moment where we decide that the destination is worth the dying. The first person to die for space was not American. On April 24th, 1967, Soviet cosmonaut Vladimir Komarov climbed into Soyuz 1 knowing the spacecraft had not been adequately tested. Engineers had filed a report listing 203 structural problems. The report was buried. The mission was politically necessary. It had to launch before the 50th anniversary of the Russian Revolution. Komarov reportedly told his superiors the mission would fail. He flew anyway, because the alternative was that his backup, his friend Yuri Gagarin, would fly in his place and die instead. During re-entry, the parachutes failed. Komarov's spacecraft hit the ground at nearly 500 miles per hour. The impact was so violent that recovery teams could not identify the remains without forensic analysis. He was 40 years old. He is the first human being confirmed to have died during a space mission. He knew he was going to die. He got in the rocket anyway, to save the life of a man he loved. We don't talk about this enough. On January 28, 1986, at 11:38 in the morning, the Space Shuttle Challenger lifted off from Kennedy Space Center carrying 7 people. Michael Smith, Dick Scobie, Judy Resnick, Ellison Onizuka, Ron McNair, Gregory Jarvis, Krista McAuliffe, a schoolteacher from New Hampshire who had beaten out 11,000 other applicants to be the first civilian in space. 73 seconds after launch, the shuttle broke apart over the Atlantic Ocean. The investigation that followed revealed something NASA had known and failed to act on. The O-ring seals in the solid rocket booster were not rated for the temperature that morning. Engineers at Morton Thiokol had raised the concern the night before. They had recommended delaying the launch. Management overruled them. That decision was made in a conference room. 7 people died in the sky. We don't talk about this enough. On February 1st, 2003, the Space Shuttle Columbia disintegrated during re-entry over Texas and Louisiana. Rick Husband, William McCool, Michael Anderson, David Brown, Kalpana Chawla, Laurel Clark, Ilan Ramon, the first Israeli astronaut, a combat pilot who had survived the 1973 Yom Kippur War and would not survive his first minutes back in the atmosphere he'd left behind. The cause? A piece of foam insulation had struck the leading edge of the left wing during launch 16 days earlier. The damage had been flagged. Engineers had requested satellite imagery to assess it. The request was denied as unnecessary. 14 people in 17 years. Both times not because the universe was cruel, because organisations under pressure made decisions that compressed the margin between acceptable risk and catastrophe until there was no margin left. Now imagine that same organisational pressure, that same compression of margins, operating on a planet where the rescue shuttle is 140 million miles away and won't arrive for 26 months, even if you call for it the moment things start going wrong. There is no rescue on Mars, there is no abort, there is no turning back. The people who go will know this. They will have read the reports, they will have studied the failure modes, they will have sat with the math at 2 in the morning and made their peace with the number that comes back. The photos won't show you what it feels like to make that peace. Behind every flag planted on alien soil is a conversation that happened quietly, in private, between a person and everything they're leaving behind. A conversation that ended with one of them agreeing not to come back. Some of those conversations are happening right now, in training facilities in Houston, in simulation habitats in the Arizona desert, in offices in Boca Chica, Texas, where engineers are calculating exactly how many people will need to die before the ones who follow them can survive. Nobody told you this part. The cost of a civilization on Mars is measured in the same unit as every civilization before it, in the people who went first and didn't make it, so that the people who came after could. It has always worked this way. That doesn't make it less terrible. It makes it more terrible because we do it deliberately, with open eyes, and we call it progress. Picture this: a person, not yet named, not yet selected, standing at a porthole window in a habitat module somewhere on the Arcadia Planitia, watching a dust storm erase the horizon. Earth is a blue dot in the black, so small you could cover it with your thumbnail, so far away that a message sent at the speed of light takes 7 minutes to arrive and 7 minutes more to receive an answer. And this person is not afraid. Not because they don't understand what Mars is, but because they understand it completely and chose it anyway. That's the thing we never quite absorb when we talk about Mars missions in the abstract, in press conferences and mission patches and carefully worded statements about human exploration. This isn't a story about a planet. It's a story about what we are. We are the only thing in the known universe that has ever looked at a hostile, frozen, radiation-soaked rock 140 million miles away and said, "That's where we're going next." Not because we have to, not because Earth is finished, but because we cannot stop. Because something in the deepest part of our biology reaches toward what is unreachable and will not accept the word impossible as a final answer. Mars will take from us. It will take more than we are ready to give. The first people who land there will pay a price that we, watching from Earth, will call heroic. Because that's the word we use when we need to feel better about what we ask someone else to do. But here is the truth that sits underneath all of it. The truth that the engineers and the astronauts and the mission planners all know and never quite say aloud. The scariest thing about Mars is not the radiation, or the dust, or the cold, or the distance. The scariest thing about Mars is that we're going anyway, and that the people who go will be the best of us, not the ones we can afford to lose, and they will go. Because that is what human beings do. We reach, we break, we reach again. Thanks for watching, and I'll see you in the next one.